In question 1a, we are told that the price of a house is €240,000 at the start of 2019. We must find its price at the start of the following 2 years. In 2019, the price increases by 8%. To find the value of the increase, we multiply 240,000 by 8%. To get the price at the start of 2020, we add on this figure to the 240,000. This gives us an answer of 259200. In 2020, the price increases by a further 9%. To find the value of the increase, we multiply 259200 by 9%. Then, to get the price at the start of 2021, we add this on to our 259200. In B, we must find the percentage increase in value of a different house. The house started at a value of 460,000 and finished at 472,000. So the increase in value was €12,000. To find the percentage increase, we take the increase in value, 12,000, divide by the original value, 460,000, and then multiply by 100. Performing the calculation and rounding to one decimal place gives us a final answer of 2.6%. In part C, we are told to sub values into an equation and solve for the unknown value of r. The given formula is f is equals to p times 1 plus r over 100 all to the power of t. We are told that f equals 370,000, p equals 265,000, and t equals 4. We can solve for r as follows. Divide both sides by 265,000. Take the fourth root of both sides. Subtract 1 from both sides. Calculate the left-hand side. Multiply both sides by 100. Calculate the left-hand side again. And round to one decimal place. Question 2a involves plotting complex numbers on an R-GAN diagram. In part 1, we must plot Z1 conjugate. This can be done using the fact that the conjugate is found by reflecting in the horizontal real axis. In part 2, we must plot Z2 and Z3. Z2 has a real component of 5 and an imaginary component of 1. Z3 has a real component of 6 and an imaginary component of -2. In part 3, we must simplify the expression 4z2 minus 5z3. We begin by writing in the definitions of these two numbers. Then we multiply out our brackets. 4 times 5 is 20, and 4 times I is 4i. Minus 5 times 6 is minus 30, and minus 5 times minus 2i is plus 10i. To finish, we combine the real terms and combine the imaginary terms. In part 4, we must find the modulus of Z3. To do this, we can use the fact that the modulus of the complex number a plus bi is the square root of a squared plus b squared. In the case of Z3, we have a equal to 6 and b equal to -2. 6 squared is 36 and -2 squared is 4. From here, we just simplify using our calculator. In part B, we are given an R-GAN diagram with 4 numbers plotted on it. we must determine which one has the largest modulus. Well, the modulus of a complex number represents its distance from the point 0, 0. Eyeballing the distances, it is clear that Z5 is the furthest away from this point, and hence Z5 has the largest modulus. In 3a, we must solve an equation for x. First, we multiply out the brackets. 3 times 2x is 6x, and 3 times 4 is 12. Next, we can simplify the 12 minus 5 to 7. Then, we subtract 7 from both sides, simplify the right-hand side, divide both sides by 6, and simplify the fraction on the right-hand side. In B, we must plot several inequalities on a number line. In part 1, x is less than or equal to 2.8, where x is a real number. Real numbers include all the decimal numbers, so we should draw a line that covers all of the points to the left of 2.8. In part 2, x is less than or equal to 2.8, but this time x is an element of the integers. This is the set of all positive and negative whole numbers. So this time we only draw dots at the whole number values to the left of 2.8. In part 3, x is now an element of the natural numbers, which is the set of positive whole numbers. The only positive whole numbers which are less than 2.8 are 1 and 2. In C, we must solve a pair of simultaneous equations. The first step is to multiply across the first equation by 4. This gives us matching numbers with different signs in front of the y. This means that the y terms will cancel when we add our equations. Now we can solve for x. We subtract 4 from both sides, simplify the right-hand side, divide both sides by 6, and simplify. This tells us that x equals 2.5. To find y, we sub this value into one of the original equations. From here, we add 2.5 and 1 to get 3.5. Then we add y to both sides. In question 4a, we are given the graph of a function, g of x. In part 1, we must estimate the value of g of 1.5. To do this, we draw a vertical line at x equals 1.5, and then draw a horizontal line where it meets the curve. This gives us an answer of 2. In part 2, we must estimate the value of x for which g of x equals minus 6. Here, we draw a horizontal line at minus 6, and then draw a vertical line where it meets the curve. The x value here is approximately minus 2.8. In part 3, we must find the number of real roots in the given domain. A root is a location where the function touches the x-axis, and our graph only touches the x-axis once. So the answer is 1 root. In part 4, we must estimate the coordinates of the local maximum and the local minimum. The maximum point has an x value around minus 1.5 and a y value around minus 1. The local minimum has an x value around 0.25 and a y value around minus 3.2. In B, we are given an equation for a different function, h of x. In part 1, we must find the derivative of h. The definition of h has 4 components in it: x cubed, 2x squared, 1x, and 8. Each of these can be differentiated individually. To differentiate a power of x, we multiply down by the power, then reduce the power by 1. So x cubed differentiates to 3x squared, and 2x squared differentiates to 4x. A constant times x differentiates to the constant, so 1x differentiates to 1. A constant by itself differentiates to 0, so the 8 simply disappears. In part 2, we must find the equation of the tangent line at the point 2, 6. We will want to use the equation of a line formula, and to use this we need to know two things: a point on the line and the slope. The point is given to us directly. It's 2, 6. To find the slope, we can use the fact that the derivative h' of x represents the slope of the tangent line. Since our point has an x value of 2, we sub in x equal to 2 into the derivative we obtained in part 1. When we perform the calculations, we find that the slope is equal to 19. Now we can use our formula for the equation of a line. Here, x1 is equal to 2, y1 is equal to 6, and m is equal to 19. So the equation of the tangent line is y minus 6 equals 19 times x minus 2. In question 5a, part 1, we are told that it costs €12,000 to lay 240 metres of railway track. We must find the cost of laying 320 metres of track. Here, it will help to find the cost of 1 metre of track as an intermediate step. We know that 240 metres costs 12,000. If we divide both sides by 240, we find that 1 metre costs 50. From here, we can multiply both sides by 320 to find the cost of 320 metres. In part 2, we are told it takes 6 people 8 days to lay down a railway track. We must figure out how long it would take 4 people to lay down the same track. The number of people and the time taken are inversely proportional. If I divide the number of people by 6, then the time taken will be multiplied by 6. Then, if I multiply the number of people by 4, the time taken will be divided by 4. This tells us that 4 people would take 12 days to complete the task. In part B, we are told that 2 towns are 120 km apart. A train makes the journey at an average speed of 180 km per hour. In part 1, we must find the time it takes the train to make the journey. To find the time, we divide the distance, 120 km, by the speed, 180 km per hour. Simplifying the fraction gives us an answer of 2/3 hours. In part 2, we are told that the train makes a return trip at an average speed of 220 km per hour. We must find the average speed for the whole journey. To begin, we should find the time taken for the return trip. This will be equal to the distance, 120 km, divided by the speed, 220 km per hour. Simplifying the fraction, this is equal to 6/11 hours. In part 1, we found that the outward trip took 2/3 hours, so the total time for the journey will be 2/3 plus 6/11, which comes out as 40/33 hours. Since each leg of the trip is 120 km long, the total distance covered is 120 plus 120, which is 240 km. To find the average speed, we divide the total distance, 240 km, by the total time, 40 over 33 hours. When we perform this calculation, we get an answer of 198 km per hour. In question 6a, we are given a function, g of x. In part 1, we must evaluate g of minus 5. To do this, we sub in x equals minus 5 into our function definition, and then calculate the answer. In part 2, we must use calculus to find the value of x which minimises g of x. The minimum will occur when the derivative g dashed of x is equal to 0. So the strategy will be to differentiate g, set the result equal to 0, and then solve for x. G of x has 3 components in its definition: an x squared, an 8x, and a minus 6. The x squared differentiates to 2x, the 8x differentiates to 8, and the minus 6 differentiates to 0. Now we set the derivative, 2x plus 8 equal to 0. We can solve for x by subtracting 8 from both sides, dividing both sides by 2, and then calculating the right-hand side. In part B, we must expand and simplify an algebraic expression. To start, we can rewrite the 2x minus 4 squared as 2x minus 4 times 2x minus 4. Then we multiply out the brackets. 2x times 2x is 4x squared. 2x times minus 4 is minus 8x. Minus 4 times 2x is minus 8x. And minus 4 times minus 4 is plus 16. To finish, we combine like terms. Minus 8x is minus 16x, and 16 minus 6 is 10. In part C, we must solve a quadratic equation. We can do this using the quadratic formula. A represents the number in front of the x squared, which is 9. B is the number in front of the x, which is 6. And C is the number by itself, which is minus 5. We sub these values into the formula, and then simplify. 6 squared is 36, minus 4 times 9 times minus 5 is plus 180, and 2 times 9 is 18. Adding the numbers under the root gives us 216, and to deal with the plus minus symbol, we split into 2 cases. In the first, we replace it with a plus, and in the second, we replace it with a minus. From here, it's a matter of doing some calculator work and then rounding. In question 7a, we are given a formula which relates the rain runoff, C, with the maximum amount of soil soakage, S. In part 1, we must find the value of C when S equals 15. To do this, we replace the S with 15 in our formula, and then calculate the answer. In part 2, we must consider the effect on C when S increases. In our formula, the S appears beneath the line in the fraction, so if we increase S, then we will be dividing by a larger number. This decreases the overall value of the fraction. In part 3, we must rearrange the equation to write S in terms of C. To start, we multiply both sides by s plus 10. Then we multiply out the brackets. C times s is cs, and c times 10 is 10c. Next, we subtract 10c from both sides, and to finish, we divide both sides by c. In part 4, we are told that the c values range from 30 to 100. We are asked to find the range of s values. Well, the extremum values of s will occur at the extremum values of c. So all we have to do is sub in c equals 30 and c equals 100 into the formula we obtained in the previous part. When we sub in c equals 30, s comes out as 70 over 3. When we sub in c equals 100, s comes out as 0. Hence, s ranges from 0 to 70 over 3. In part B, we have a function, p of t, which tells us the probability it is raining t hours after the start of the day. In part 1, we are asked to find p of 0 and p of 24. For p of 0, we sub in t equals 0 into our function definition, then calculate the answer. P of 24 is similar, but this time we sub in t equals 24. In part 2, we must find the derivative of p of t and explain what this derivative represents. The definition of p of t has two components, a 0.3 and a 0.02t. Each of these can be differentiated individually. A constant differentiates to 0, so the 0.3 simply disappears. A constant times t differentiates to the constant, so 0.02t differentiates to 0.02. In general, a derivative represents a rate of change per unit time. In this context, p' of t equaling 0.02 means that the probability of rain increases by 0.02 with each hour that passes. In part 3, we are told that at a certain time there's a 0.35 probability that it is raining. We need to find the probability that it's raining 1 hour later. Well, in the previous part, we found that the probability of rain increases by 0.02 with each hour that passes. So the answer is 0.35 plus 0.02, which is 0.37. In question 8, we are given a diagram of a rectangular garden which contains an irregularly shaped pond. In part 1, we must find the area of the rectangle. To do this, we multiply the length, 50 metres, by the width, 30 metres. This gives an answer of 1,500 metres squared. In B, we must use the trapezoidal rule to estimate the area of the pond. To begin, we write out the trapezoidal rule from page 12 of the formula book. H represents the distance between measurements, which is 3. Y1 is the width of the first measurement, which is 0. Yn is the width of the last measurement, which is 2. And the other y values represent all the measurements in between. 10, 14, 12, 10, and 8. When we simplify the sum inside the square brackets, we get 110. And then when we multiply by 3 over 2, we get our final answer of 165 metres squared. In C, we must suggest a way in which we can get a more accurate estimate using the trapezoidal rule. One way to do this is to decrease the distance between measurements. For example, we could measure the width every 1 metre instead of every 3 metres. In D, we are told that the non-pond area is covered in grass. The grass is being resown at a cost of €2.55 per square metre, and we need to find the total cost correct to the nearest €10. Well, the area of the grass will be the area of the full rectangle minus the area of the pond. Earlier, we found that the area of the rectangle was 1,500, and in this question we are told the area of the pond is 172. Subtracting tells us that the area of the grass is 1,328 metres squared. To find the cost, we multiply this figure by the cost per square metre, €2.55. When we perform the calculation and round to the nearest €10, we get a final answer of €3,390. In part E, we know that the cost of materials was £840, including import duty of 16.9%. We must find the cost before import duty. Well, if the cost before import duty corresponds to 100%, then the cost after import duty will correspond to 116.9%. And we know that this will be equal to £840. We can divide both sides by 116.9 to find what 1% corresponds to, and then multiply both sides by 100 to find 100%, the cost before import duty. Rounding to 2 decimal places gives us a final answer of £718.56. In F, the gardener pays 2.5% commission on the £840. We are given the conversion rate from euros to pounds and must find the overall cost in euros. The first step is to find the commission. 840 times 2.5% comes out to 21. So the total amount in pounds will be 840 plus 21, which is 861. To convert to euros, we divide this number by the given conversion rate of 0.8547. Rounded to 2 decimal places, this gives us a final answer of €1,007.37. In question 9a, we are given a graph comparing T, the time in days, with the daily number of new cases of a disease. The actual number of cases are represented with dots, and a model for the number of cases is represented by a smooth curve. In part 1, we must estimate the actual number of cases when t equals 12 using the relevant dot. Well, this dot represents day 10, so this dot will represent day 11, and this dot will represent day 12. The number of cases at this dot is approximately 1,500. In part 2, we are told that the model estimates 1,000 new cases when t equals 12. We must calculate the percentage error of this estimate. From part 1, the true value of new cases on day 12 was 1,500. The estimated value from the model is 1,000. The absolute error will be the difference between these two numbers, which is 500. The percentage error is found by taking the absolute error, 500, dividing by the true value, 1,500, and then multiplying by 100. Performing the calculation and rounding to the nearest percent gives us a final answer of 33%. In part 3, we must show that it takes approximately 5 days for the daily number of cases to double, according to the model. Well, on day 12, the model predicts around 1,000 cases. 5 days later, on day 17, the model predicts around 2,000 cases. This illustrates that over a 5-day period, the cases have approximately doubled. In part 4, we must estimate the day when the number of new cases first exceeds 100,000. To do this, we will use the fact that the cases approximately double every 5 days. We have seen that day 12 has 1,000 cases and day 17 has 2,000 cases. 5 days later, on day 22, the cases will double from 2,000 to 4,000. Then, on day 27, the cases will double again to 8,000. Continuing the pattern, we expect day 32 to have 16,000 cases, day 37 to have 32,000 cases, day 42 to have 64,000 cases, and day 47 to have 128,000 cases. The first time this sequence exceeds 100,000 cases is on day 47. So this is a good estimation for the first day that the cases exceed 100,000. In part B, we are given a function, d of t, which models the number of daily new cases for a different disease. In part 1, we must fill in missing values in a function table. This involves subbing in the given t values into the function definition. Subbing in t equals 0 gives an answer of 2,100. T equals 1 gives an answer of 2,478. T equals 3 gives 3,450. T equals 4 gives 4,071. And t equals 5 gives 4,804. In part 2, we need to graph these points. We do this by plotting a point for each of our pairs, and then joining the dots as best we can with a smooth curve. In part 3, we are given a function, k of t, which tells us the number of new cases after measures have been put in place to slow the spread of the disease. We are told that when t equals 14, we have 21,309 new cases. We must solve for the unknown value of a. We begin by replacing the number of new cases, k of t, with 21,309 and replacing t with 14. Next, we divide both sides by 0.83 to the power of 14. Then, we do some calculator work to simplify the left-hand side. The question asks us to give our final answer in scientific notation. We can convert to this form by moving the decimal place 5 positions to the left and then multiplying by 10 to the power of 5. We round our number to 2 decimal places to get our final answer. In question 10a, part 1, we must find the volume of a cylinder. Page 10 of the formula book tells us that the volume of a cylinder is pi r squared h, where r is the radius and h is the height. The diameter of the cylinder is 18, so the radius will be 18 over 2, which is 9. The height of the cylinder is 5. Subbing these values into our formula, using our calculator, and rounding to the nearest whole number, gives us an answer of 1,272 millimeters cubed. In part 2, a ring is formed by removing a portion of the cylinder. We must find the volume of the ring. Well, the inner cylinder has a diameter of 14, which means it has a radius of 7. It has a height of 5. So the volume of the inner cylinder is pi times 7 squared times 5. This comes out to 245 pi. To find the volume of the ring, we take the volume of the big cylinder, 1272, and subtract the volume of the inner cylinder, 245 pi. When we perform the calculation and round to the nearest whole number, we get an answer of 502 millimeters cubed. In B part 1, we must find the percentage weight of gold in a ring. To do this, we take the weight of gold, which we're told is 3 grams, divide by the total weight of the ring, which we're told is 8 grams, and then multiply by 100. This comes out to an answer of 37.5%. In part 2, we know that pink gold is made up of pure gold, copper and silver in the ratio 15:4:1. We must find the weight of pure gold in a pink gold ring that weighs 25 grams. Well, in total, we have 15 plus 4 plus 1 equals 20 units. In total, the ring weighs 25 grams. Hence, 20 units corresponds to 25 grams. Dividing both sides by 20 tells us that 1 unit corresponds to 1.25 grams. Since we have 15 units of pure gold, we should multiply this by 15. This gives us a final answer of 18.75 grams. In part 3, we are given the percentage components in rose gold. We have 75% pure gold, 22.25% copper, and 2.75% silver. We must express this ratio using whole numbers in their simplest form. To begin, we can convert each of our figures to decimal by dividing by 100 and removing the percentage symbol. Then, we can type each of these decimals into our calculator to convert them to fractions. The lowest common multiple of the denominators in these fractions is 400, so we should multiply each term by 400. This gives us a final answer of 300 to 89 to 11. In C, we are given a table which details the cost of insuring jewellery. In part 1, we must work out the cost of insuring a ring valued at €1,800. The first €1,000 in value gets charged at 1%, which is 1 over 100 as a fraction. Multiplying 1,000 by 1 over 100 gives us 10. The remaining €800 gets charged at 2%, which is 2 over 100 as a fraction. Multiplying 800 by 2 over 100 gives us 16. To find the total cost, we add the 10 with the 16 to get a final answer of €26. In part 2, we are told that the cost of insuring a necklace is €142.80. We must find the value of the necklace. Well, the first €1,000 in value gets charged at 1%, which comes out to €10. The remaining X euro in value will get charged at 2%, and this comes out to 0.02x. We know that when we add these figures, we must get an answer of 142.80. This gives us an equation which we can use to solve for x. First, we should subtract 10 from both sides. Then we should simplify the right-hand side. From here, we can divide both sides by 0.02 and simplify. This tells us that x, the value that gets charged at 2%, is equal to 6640. To find the total value of the necklace, we must add on the €1,000 that was charged at 1%. In part 3, a brooch is valued at €17,500. The cost of insurance is €435, and we must use this to find the value of R. According to our table, the first €1,000 in value gets charged at 1%, and this comes out to 10. The next €9,000 gets charged at 2%, and this comes out to 180. The remaining €7,500 will get charged at R%. This comes out to 75R. Adding these three figures will give us the total cost, which we're told is €435. This gives us an equation which we can solve for R. To start, we simplify by adding 10 to 180. Then, we subtract 190 from both sides and simplify on the right-hand side. From here, we divide both sides by 75, calculate the right-hand side, and then round to one decimal place.